Bismillahirrahmanirrahim. Today I'd like to talk about the concept of radians. Now, radians is another way of measuring angles. Now, we are used to measuring angles using degrees. So let's say if I have an angle over here like this, then I could say this angle measures, for example, I don't know, maybe 40 degrees. So we would say this is a 40-degree angle. And as we recall, in a circle, there are 360 degrees. In other words, if you have an angle that starts like this and goes all the way over here, that would be a 360-degree angle. So a turn that's all the way across like this, that's a 360-degree turn. So what we have done is we have divided the circle into 360 degrees. So 1 degree, for example, might be like that. And so this is like a 1-degree angle. If you take 360 of those, you'll have a complete circle. Now, this is a bit arbitrary. Nobody really knows why the circle is divided into 360 degrees. And the best guess, perhaps, is that people in the ancient days realized that in a year, there are approximately 360 days. So they divided the circle into 360 parts, and each little part representing 1 degree. But if you were to go on a different planet, the year might be longer or shorter. What if the year was like 500 days long or 2,000 days long or something like that? So this 360 degrees of a circle is a bit of an arbitrary concept in that way. It's a very useful concept. Clearly, mankind has done quite a bit with the 360 degrees. Now, radians is another way of expressing angle measurements. So, for example, this angle might be 30 degrees, right? Now, radians would be another way of expressing the same angle. Now, somebody might say, why do we need radians, right? Didn't 360 degrees work just fine? Well, they do kind of. In fact, they do up until geometry. But beyond that, if you do calculus and things, you can't really use degrees. Because degrees are kind of like 12%. When we say degree of something, it's a symbolic way of expressing something. So what is radians, you say? Well, the concept is a little trickier for some students to understand, but if you bear with me for a little bit, it might prove very useful. So imagine this circle over here, and I'm going to draw out its radius like this. Radius r. Now, imagine that there's a tiny little ant, okay? Little tiny ant is crawling on this radius. It's discovered this radius, and it's so excited that it wants to go back and tell everybody what it's discovered. So it's walking there from the center. It's going all the way over here, okay? And then it says, I'm going to figure out how big this circle is, and I'm going to go back and tell all my friends about it, okay? So it starts over here at the center. It's traveling over here, goes over here. And then it says, well, I'm going to figure out how big this circle really is. So then, I'm going to go up. So it goes over here, 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 goes over here. And then and then it stops right there and says, you know what? This is the 1 radius worth of length. So it goes, it's very smart, because ants are pretty smart. You got to give them credit. So it goes from here to here, knows how big the radius is, travels over here, and cuts out an arc that is the size of the radius. You follow? So now it has cut out this arc over here. Now this angle created over here, this angle right here, is 1 radian. In other words, this is a reference angle. The angle that's created by the intercepted arc, not just any arc, the arc the size of the radians. So 1 radian is the angle that's created by an arc, not just any arc. It's an arc whose length is exactly as the radius. This angle is called 1 radian. Now let's get back to our story. Now this ant is on a mission, okay? So it's going to keep going over here. So it keeps going and says, I'm going to tell my buddies how big this circle is, and goes over here. And then it says it marks over here, okay? And it says, okay, that's the 2nd time I've done this. So that's another one, right? Then it keeps going. It gets all the way almost to the halfway point of the circle. Almost to 180 degrees, almost half a circle, right? But the little part of it is missing here. How much of it's missing? It ends up being 0.14 approximately, because, in other words, in half of a circle, there's a little over 3 radians worth of angles. Now, one thing you observe about radians is that they're smaller numbers, right? It's like, by this time, you're like 175 degrees or something like that. You're talking about, in a circle, there's like 1 radian, 2 radian, 3 radians. Right here, a little bit left over. How much exactly? It ends up being, in a semicircle, there's pi radians. In other words, pi is approximately 3.14. In other words, 3 radius plus 0.14 of a radius right here. So in 180 degrees, there is pi radians. In 180 degrees, there are approximately 3.14 radiuses or radians. Okay. Now, here's a more formal definition of a radian. So 1 radian is the measure of the angle. 1 radian is the angle subtended or the angle created. So the arc is intercepted and the angle is said to be subtended. The angle that's created by the arc is the subtended angle. So 1 radian is the angle created or the angle subtended by an arc whose length is the same as the radius of the circle. Now there's something very important that you must understand. So what I've done here, I've created 1 radian angle right here based on this blue. But then you must understand it's going to be the same for all of these circles. In other words, if you take the white circle over here and make 1 radian, that's going to be this arc. The blue circle is going to be that arc. And if you take the yellow circle over here, take its radius, that's going to be that. And then take the purple circle and its radius over here, this arc over here that's going to be created here is going to be worth R radians. In other words, 1 radian is going to be the same angle for all circles because it's a ratio. It's a ratio of the radius to the arc intercepted, and that's going to be the same for all circles. In other words, 1 radian is going to be the same for all circles. So this angle right here, this angle over here, let's call it theta. This angle is 1 radian. The arc length for all of these is different, but the ratio of the radius to the arc length is going to be the same, right? Because it's going to create this 1 angle over here. So what I've tried to do over here is to formally describe to you what radians means. So what we understand is that 1 radian is the angle that's created or subtended by the arc whose length is the same as the radius of that circle. And this is a universal phenomenon that is independent of anything else but the circle itself and the properties of the circle. In the circle, the circumference, as you recall, is defined as 2 times pi times r. Now, pi is approximately 3.14, so you can rewrite this as 2 times pi, which is approximately 3.14, times the radius. And if you multiply this out, you get 6.28 r. So you can say circumference is approximately 6.28 r. In other words, there are approximately 6 radiuses in a circumference, or 6 radians in a circumference. So there are approximately 6.28 radians in a circle. In a circle, as you know, there are 360 degrees. And as we have suggested, that's 2 pi radians. So 360 degrees is 2 pi radians. And that's what we use to convert between radians and degrees. Or alternatively, 180 degrees is pi radians. Until next time, as-salatu wa-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.